start recording, and I will screen share Chapter 7 PowerPoint with you guys. Now, I'm not the biggest fan of the textbook PowerPoints, so I don't typically use them even when I teach in class. But with some of the application-based problems, they do kind of provide a little bit more information than what's on the teacher notes. So in that regard, if you guys feel like what's on the teacher notes isn't like good enough, typically what happens is, if you notice our number 9 here is matching up with example 9 on this PowerPoint. If you go into the PowerPoint, it typically will have more information. So I don't know, there's that info for you. So if you notice, here we go. They went ahead and they put in their L1 and L2s, which, does anyone need me to go over that real quick? Re-explain. It's from last exam, so you should be good with it. So basically what they decided to do is they put it in, and then they kind of noticed, well, this 8 and 17.5 is kind of nice. It falls kind of in line with the data points. So they select the highest data point, which is 423, to be the vertex, which that kind of makes sense, right? You can see even with the data you're given that you were going up, and then you hit the highest point, and then you're starting to come back down. So it says a parabola with the vertex might also contain the data point 8 and 17.5. So you can use the approach we were talking about on Monday. I just kind of feel like the math involved might be a little bit advanced for what we're going for, and I don't want you guys to get like super confused. Hold on a second. Okay, so we're gonna go with this approach, and we're going to use this to solve for A. So if you look, they're taking their 17.5 and their 8, and they're plugging it into the formula, which is the formula for a vertex of a quadratic, and then they're solving for A. Once they have that approximation, they then find their f of t. So this is the solution I want you to write down for 9A. Okay, so let's go on to part B. As you can see, if you went ahead and put in your quadratic, you can see that it kind of nicely lines up. Now, this does not mean that that is the only quadratic equation that would fit that exact data. That's why whenever we did it using the quadratic regression, we got a little bit different answers. More likely than not, if you would have plugged that in, it also would have been fairly good. So just kind of keep that in mind. For part B, it wanted us to estimate 15,000 international adoptions. All you had to do was solve your original equation for 15. And when you do that, you're actually going to end up with 2 solutions. Does anyone know why? Why would it make sense for you to have 2 solutions?
We're working with parabolas.
Right, so when you're working with parabolas, unless you're talking about the vertex point, all other inputs are going to have 2 solutions. So they're kind of going to run parallel to each other in a way. Very good. All right, so to finish that out, you can see here that they went in the negative root and then the positive root. You end up getting t is approximately negative 0.85, or t is approximately 8.85. And we discussed why that happens, but in terms of what it means to your problem, if you add and subtract those onto your given amount, which I think it was since 2000, then you're looking at 15,000 international adoptions in the US in both 1999 and 2009. I don't know the actual data to that, so it's possible. If you really wanted to look it up, you could. If it were different, you could then find an error statistic, which would be interesting for you. Okay. The next thing I want us to do is we were going to pick up with number 19. It's decent to have. Let me take a minute and write that down. Oh, I know I had you guys do some independent practice. I wrote it down. So it was numbers 6 and 7, 13 and 14, 16 and 17. So if anybody needs those, flag me down as I'm going through the PowerPoint and we can easily take a look at those. If anyone wants the actual steps to completing the square, you can write them down here. I kind of like my simplistic way of explaining it, but if you would like the actual steps, you can write them out. They're definitely more complexly written than the way I taught you it. You can go ahead and write that one down. If you didn't write it down last time, this is actually written really nicely because once you find the determinant, remember we discussed how it tells you the number of solutions and types of solutions. So if the discriminant is greater than 0, there will be 2 real solutions. If it's equal to 0, it's saying 1 real solution there, but what it really means is that you have 1 real solution with a duplicity, meaning that you would get that answer twice. And then when it's less than 0 or negative, you have 2 imaginary solutions or 2 non-real solutions. Clearly that bonus would be due before the 20th because your exam is due on the 20th. So if you would like to get that to me by, let's say, Wednesday-ish, because I'm only probably going to put a couple of them on the actual exam, and most of the time if it's bonus, people ignore it. But hey, you'll get bonus for creating it, you'll get extra bonus if I pick yours, and then you'll also get bonus on the exam. I think I'm awesome. All right. So this is example 19, modeling with a quadratic function. Annual consumption of bottled water in the United States has been increasing since 1990. And then if you take a look, you have your nice little data table there, which I am definitely glad that I showed you the PowerPoint for it, because you would have been slightly confused as to where I was getting the information. So if you're interested in writing this example down, go ahead and write the table out, and or if you choose, you can always rewatch the video, which I will add to the YouTube channel this evening, hopefully. And just so you guys know, I have been keeping up with the YouTube channel, but I think what happens is I forget to bring it over into Canvas. So if you go and click, you should be able to get into the playlist, and then you can follow it from there. If you have an issue though, and you really need something that you don't see, just email me and I'll try to put it up there. All right. So we're gonna let F of T be the annual bottled water consumption in billions of gallons at T years since 1990. Notice how they're saying a possible equation of F is equal to F of T, and then it gives it to you. That's probably because you're dealing with data. So anytime you're dealing with data, you can have issues with human error, you can have reliability issues. So they're really trying to get you into the mindset of being a researcher, and that's why they're using the wording they're using. Okay, in terms of pure math, it's probably going to work out. All right, so for part A, we want to verify that F models the data well. So it says predict when annual consumption will reach 20 billion gallons. So if we're trying to figure out 20 billion gallons, where are we going to put the 20 in?
T?
Well, so T is typically time, right? So
Oh, the F of T?
there you go. That's what we wanted to realize. So yeah, you're gonna go ahead and you're gonna put it in for F of T. All they're doing on this slide is kind of giving you, they plugged in their data points using the stat plot, and then they plugged in their given F of T. You can do it, you can choose not to do it, you can just assume that they're giving you correct information. On your exam, if you try to draw out your data points, actually, before I talk out of my butt, let me see if you even have one. You don't, so don't worry about it. You do need to know how to do this. There may or may not be one on the final. But anytime you have a situation like this, if you want to draw out, roughly sketch out the diagram, I will probably give you bonus points. Because in math and higher sciences, the more you get used to and trained to drawing out the diagram, the better you guys will be. And my ultimate goal, other than getting you to understand the concepts of algebra, is to also understand how to be the best math science person you can be. So yeah, the more pictures you draw for me, and please don't draw me little stick figures, although I'll probably laugh, I'll ask you why you thought I would give you a point for that. Though remind me later, I do have a side story about stick figure drawings. Okay, so to predict when annual consumption will be 20 billion gallons, substitute 20 for F of T, as Gavin told us, and solve for T. You're going to end up with two options again. Why? Same rationale as before. It's a quadratic. It's not your vertex, so you're going to end up with 2. However, we're going to find something interesting out in a moment. So I want you guys to think about it, what you possibly could come up with. All right, assuming you're all good there. Here we notice that T is approximately negative 30.04 or 28.14. Now, before we had two answers, one of them was negative and one of them was positive, and we were dealing with time, so we just subtracted away from the given year, which in our case is 1990. So roughly 30 years prior to 1990 would have been 1960. Now, 1960 existed, It's not like we went from 1959 to 1961. 1960 did exist. However, do you feel that in 1960, 20 billion gallons of water was consumed either in the world or US, whatever we're working in? Do you think that's a possibility in the 1960s? No. So what happens is we say that for T minus 30 or for 1960, we have what's called a model breakdown because the application there just doesn't make sense. Now, the predicted, in this case, predicted 2018, that makes a little bit more sense, right? Way more people, way more water being consumed. We're going to assume there wasn't a model breakdown there. Does that make sense for everyone? Okay. For some reason on the teacher notes, we did not talk about number 2, so we're not going to worry about it. All right, moving on. Here is your super easy example. This is what you want to star and asterisk and highlight, whatever you want to do, circle, I don't care. You could draw little stick figures dancing. These are the 2 problems that if you make up your own and you send them in to me, then you can get some extra credit on your test. Basically, the way this works is you have to decide whether the given ordered triple is a solution for the equation. So someone tell me your ideas of what you think we might be able to do. Yes, granted, I understand you normally are just used to looking at X's and Y's, and now we're throwing a Z at you. But what do you think we can do with that Z? Or any of them, to be honest. What can we do? I'll give you a little hint. Typically, it goes in alphabetical order. So this is X, this is Y, and this is Z. Which means this will also be X, Y, and Z. Does that help? Good. So what are we going to do with it?
I guess you just start.
You can go.
Okay, I guess you can just start by like plugging in the numbers into the equation.
Very good. So we're going to take 5 times -3 minus 2 times 1 plus 4 times 7. And the question is, if we do all that, will it equal 11? Well, we have -15 and -2 and then a plus 28. So does -17 plus 28 give us 11? It does. It checks. Therefore, you would say, yes, this triple is a solution. Okay? Now, we can't just look at the other one and go, that's not going to work because A worked. We don't know. We have to plug it in and find out. So 5 times 2 minus 2 times -9 plus 4 times 6 equals 11 question mark. Okay, so 10 plus 18 plus, what was that, 24. Now, before we even finish, do we have to finish? What do you notice? Those are all positive numbers, right? So you are not going to get to 11. So this is a no. Okay? But you can't just automatically look at it and go, yes and no. I don't really care. There we go. I'll get it right because I have a 50-50 chance. I highly suggest you work the problem out. Now, don't get me wrong. If you want to play the 50-50 chance game and you get it right, I technically, based on the way that I do things, can't really take points away from you. But you're kind of risking losing all of it if you get it wrong. So, because I'm not going to give you any points for a yes and a no. There are no partial credit given for a yes and a no. All right, everybody good on that? Do we see why that's a pretty easy bonus question? Okay, so make your own up, get at least that bonus point, and then if I pick yours, I'll give you another one, and then if you do it, there you go. So, I mean, really, I don't think you could get any better than that. All right, so we don't have to look at those because we just did it. I don't think you need to write all that. So we are going to look at, they call it example 19. It's really example 21 for us. So typically I would work this problem out for you, but we do have the lovely PowerPoint, so we can actually use their ink instead of mine. Granted, my ink is also digital, so I guess I'm not really saving the environment, but we'll pretend I am. Okay, so we have equations 1, 2, and 3. What can you tell me is a little bit different from this system than what you're used to working with?
It has a Z.
Yeah, so because we have 3 variables, notice how many equations we have to have. You have to have the same number of equations as you do variables. So if you were given so if you were given an X and a Y and you were told to solve this, the best you can do is solve it in terms of the opposite. You can't actually get a number out unless you're either A, given a substitution, or B, given a second equation. So it's the same thing with this. Unless you're given a substitution or you're given the 3 equations, you can't solve it. All right, makes sense? Okay, so here's the first thing we're going to look at. And they like to give you words. So I will read you the words. By inspecting the coefficients of the 9 variable terms, we see that the easiest to eliminate is y. So we add the left sides and add the right sides of equations 1 and 2. That's basically just helping you eliminate your y. If you eliminate your y, you can then write things in terms of another variable. For instance, if you look at equation 4 now, what do you know about z right here? Z has a coefficient of what? 1, and it's positive. So if we move this negative 3x over, we now have something written in terms of x that is z. So we can take that and plug it back in. So let's look and see what they do. So, okay, so they're choosing to get a 5th equation. I would have probably just started doing things, but then eventually I would have come to this. So we'll do it their way. So we're going to multiply equation 1 by 2, and we're going to add it to equation 3. And the reason for that is because, again, what are we eliminating here? We're eliminating the y's. So now we're working down to an equation set where you have an x and a z, and that's it. Okay, so we're going to eliminate the z's, and we find x. Now that we have a variable, we're really happy, right? So now you're down from having 3 unknowns to only 2 unknowns. Okay, we're going to substitute x in, and we find z. We're going to substitute x and z in, and we find y. Okay. This is probably a good series of slides to go back and pause me on in the future. Okay. So the last thing you want to do, this is extremely important. So you have one of the, I won't lie to you, you have one of these on the exam. You have a system of 3 equations. You have to find it. You can choose not to check. If you do everything and you think you're right and you don't want to check, that's your decision. I will go through and I will give you the points that I can give you. And if you get it 100% right and you didn't check, I will give you all the points. However, If you think you messed up, going through and writing the check is exactly how you've determined if you messed up or not. You will not get anything but true answers if you did it correctly. It's not like you get 2 true and 1 false. They all have to be true, okay? So it's basically an internal check for you. You would 100% know if you got that problem exactly right if you do the check. I might even be willing to give you bonus points if you show me the work for the check. It'll probably depend on my mood. More than likely, it'll depend on how many of you choose to do the check. If I only have 2 or 3 people doing the check, then you can bet those 2 or 3 people are going to get bonus. No joke, that's how I roll. Okay? Questions on this type of problem? It's pretty similar to your standard 2 equation system, but some people see that third variable and their brains kind of stop. All right, you can take a minute and write this down if you really feel like you need it. You want to select a pair of equations and eliminate a variable, and select another pair of equations and eliminate the same variable as in step 1. So if you eliminate one variable in step 1 and then you choose to eliminate a second variable in step 2, not really helping yourself out any. Okay, you want to eliminate the same set of variables. Okay, I guess I'll pause it there. And then the equations you found in steps 1 and 2 now form a normal 2 variable system. Use elimination or substitution to solve the system. You plug them all back in, you write your ordered triple. I guess this is where the ordered triple is coming into play for your exam. But like I said, really, I would prefer you to come up with some of those questions. All right. We already talked about that. Do we need to know this? You don't need to plot. Although, if you do end up plotting something like this, if you really, really want to wow me on your test and you plot me something like this, I don't even know how many bonus points I would give you. I would be over the moon, ecstatic, so geeking happy. Like I said, I don't even know. I might give you 10 bonus points because it's an XYZ plane. There are a triple in it. It's drawing it out. Yep, I would say that I would be happy enough to give you 10 bonus points for that. Or somewhere around there, if you gave it a try and it just turns out kind of gross and ugly, I still might give you points for it because that would be showing me that you are taking the class seriously and you are really trying to go above and beyond with your education. I would be super stoked to see that. All right. Obviously you don't need to know anything about that. Okay. This is the big guy, okay? This is the one where you have to kind of bring it all together. Not only are you going to solve a 3-variable system, but then once you solve that 3-variable system, you are going to create a quadratic equation out of it, okay? So you are going to use A, B, and C. You're going to use those variables for a specific reason. That reason is you are used to seeing them for the standard equation of a quadratic, okay? How am I doing on time? Oh, okay. We're good. All right. So, like I said, we're going to start off with the 3 system, but you have to actually create it. So that's where this problem becomes highly tricky, okay? So, I'm going to walk you through this. All right. Give me my writing tool. Thank you. All right. So to find equation 1, I guess we'll just write out EQ, so you guys don't think that's part of it. So equation 1, we are looking at the point 1, 1. So in a regular standard quadratic. We have ax squared plus bx plus c. Okay? We're now going to put in the 0.11 and clean it up. So if we put in 1 for y, 1 squared is just what? 1. So we have a. 1 times b gives us b plus c. That's it for equation 1. Okay? Now we have to create equation 2. It's going to be a little bit grosser. So now you have to put in the 0.23. So 3 is our y. 2 squared is 4, so 4a. 2b plus c. Equation 3. We get 9 out. 3 squared is 9, so 9x, or I'm sorry, 9a. 3b plus c. Okay. You will follow those steps every single time. You plug in 1 point, you get out one equation. You plug in the second point, you get out the second equation. You plug in the third point, you get out the third equation. You can choose, if you really wanted to, you could rewrite these to make it look more like you're used to seeing. You don't have to. You can still solve it the other way. But if it makes people feel better, if it makes you feel better, I will do it because I'm nice like that. And you can do it from the beginning too. If you're good enough to kind of see it in your head, you can choose to rewrite it like this. All right. Everybody on the same page with that? Okay. All right. Hoping everybody paid attention to me because it's going away. All right. You can see here they broke it down. They kept it kind of broken for you. And then here they agree with us. Okay. All right. Now comes the fun part of eliminating. Okay. So they're choosing to eliminate C, which if you go back here, why is C the best option to eliminate? Take a look at those 3 equations. Tell me why you're eliminating C.
It's the only variable that doesn't have a number in front of it.
Right, that number is 1. Okay, so because consistently C we got lucky. Well, I guess not really lucky because the standard form, it just has C. So they're choosing to get rid of C. All right, and if you're finding a parabola, which hint, hint, that's what you're doing on the exam. So if you can follow this exact example, you are golden for that problem. All right, so we come in and we're going to eliminate C by multiplying equation 1 by a -1. You're going to add it to equation 2, and you end up with 3a plus b equals 2. All right, that becomes equation 4. All right. The next step they use is they again multiply equation 1 by -1, and then they add it to equation 3, and now they get equation 5, which is 8a plus 2b equals 8. They then decide to do an extra step, and we'll see why in a second, why they chose to do this. They're dividing equation 5 by 2. and they're getting equation 6. So they get 4a plus b equals 4. Now, why do you think they chose to do that? What does that allow us to do easily? A little bit more easily than before. What do you notice about your b's? They both, very good, go ahead.
I was going to say they cancel out.
They are going to cancel out because we're going to multiply everything by a -1, and they have a coefficient of 1. If we wouldn't have done that, this b right here would have still been a 2b. Now, there's two different ways you could have approached that. You could have divided the equation 5 by 2, which they did. The other approach is instead of doing any division and getting a third equation and potentially getting confused, you could have left it as 8a plus 2b equals 8. What you would have then had to do here is instead of multiply by -1, you would have multiplied by -2. And you still would have worked out to get the same answer, a equals 2. All right? As long as you can do those little things, you will be completely fine with the exam, okay, for this problem. So basically, these slides here will definitely help you with that part of the exam. Obviously, if you practice it beforehand, you won't have to look at the slides. All right? So then you just go ahead and you find your solution. And once you find your solution, you do have to write it as a function. You can't write it as a triple. The directions specifically state what is the equation of the parabola. Okay, this is not finding a solution like it was before with the triple. This is finding an equation of a parabola. Okay, two very different things. Do not draw me the super cool XYZ plane of this problem. I will just give you a big sad face. Yeah, be like, this is not an equation. This is really pretty, but it's not an equation. Okay, so that concludes chapter 7. Does anyone have any conceptual questions for me on chapter 7? Okay. With the time, oh, why didn't that do what I wanted it to do? Weird.